G'day Standard Maths champions, welcome back to the first and only maths channel on YouTube. Today we are starting off with a flashback question on probability. I've got a bag containing 50 cent, $1 and $2 coins, which are virtually useless these days, but if 30% of the bag are $2 coins and the probability of picking $1 is 0.25, which equates to 25%, find the probability of picking a 50 cent coin. Pause the video, see if you can crack the code, and I'll have the answer up very shortly. Alright, so we have the probability of getting 50 cents, or $1, or $2 must equal 1, because those are the only three options, yeah? It's either this, or this, or this. Add them up, and you've got 100%. Okay? If 30% of the bag are $2 coins, it means the probability of $2 is going to be 30%. And the probability of picking $1 is already given to us, it's 0.25. I'm just going to work in decimals for today because I'm feeling very adventurous. And now you can just solve this equation for the probability of 50 cents. It's a pretty quick answer. You end up with 0.45, which is 45%. So well done if you managed to get that. For today's lesson, we are looking at what's called complementary events. So a good first question to answer is, what is a complementary event? Well, first of all, we're going to look at a bit of notation. So if I'm using E as a letter to represent an event, if I put a little fancy hat on my E, this represents the complement of the event E. Okay? And when I say the complement, I mean everything that's not E. Okay? So the complement of E is all the outcomes in the sample space that are not E. Okay? So to make sense of that, if, say for another letter, if we said A, the event A represented rolling a 3 on your standard 6-sided dice, then the complement of A with a little hat on, that would be represented by everything that's not rolling a 3, which means rolling a 1, 2, 4, 5, or 6. Okay, so you've got an event, and you've got the complement of the event, which is just everything else, okay? And a useful little fact is that the probability of an event plus the probability of the complement is like saying, well, let's just say E is rolling a 3 on a standard die. What's the probability that you roll a 3 or you don't roll a 3? Well, it's going to be one or the other, so the probability is 100%, which is 1. Okay. For our first example, we have the Sharks playing the Raiders in NRL, which I'm sure we're all missing very much. We're going to let A represent the Sharks winning. I want you to think about what the complement of that event would be. Okay, the complement. So if A is going to be the Sharks winning, well, the complement of A is going to be the Sharks not winning. Okay, so you can write Sharks not winning, or another way you could say that is that the Raiders could win, or the other option is that the Sharks and Raiders could draw. Okay, or you can just say Sharks not winning, that's probably the best answer. And now if I'm saying that the probability of what's A? A is the Sharks winning. If I'm saying the probability of the Sharks winning is 33 out of 50, what is the probability of the complement? And we're going to answer as a percentage. So if I told you there was a 33 out of 50 chance that the Sharks pull it off, what would you say is the probability that they don't win? Okay, if you're looking at this thing saying, well, if the 33 out of 50 is the Sharks' chances, the leftover must be their not chances, which is a terrible way of putting it. So the answer is 17 out of 50, okay? Because the probability of the event and the probability of the complement need to make 1. So it's always just what's the leftover, okay? You can probably just get straight to that answer by saying, well, 33 out of 50 chance they do it. So the leftover is the 17 out of 50 chance that is your complement. Okay, and so the shortcut is you can just do 1, take away the probability, and it will leave you with the probability of the complement. Hope that makes some sense. We'll do one more example to really wrap our heads around this. Oh, sorry, we were supposed to answer as a percentage, which is 34%. Beg my pardon. For the next example, we have a biased 4-sided die is thrown. So bias means that each of the sides doesn't have an equal chance. So a usual six-sided die, all the faces have a 1 in 6 chance. This one is a bit biased, so one side could be more favorable than the others, okay? Here it is down here. So if I rolled it like this and all the 4s are pointing up, this would be rolling a 4. So the info is, from our 4 sides, the probability of getting a 1 is a fifth. The probability of getting a 2 is 0.3, so 30%. And the probability of the complement of 4 is 60%. So the way we can read this is that the probability of not getting a 4 is 60%. See if you can pause the video and have a go at these 3 questions. The last one's a bit of a trick, which you probably might be confused by, but you're welcome to try. So for the first one, if the probability of us not getting a 4 is 60%, that means that the probability that we do get a 4 needs to be 40%, yeah? So if the probability that we don't pull it off is 60%, the probability that does happen is the leftover in 100%, which is 40%. I hope that's straightforward. For the next one, the probability of 3, which I haven't mentioned up here, but there's only 4 options in the sample space, 1, 2, 3, or 4, and you know the other 3. So we know that the probability of 1 or 2 or 3 or 4 altogether is going to make 100%, yeah? So we can substitute in the fact that we know the probability of 1, we know the probability of 2, and in the last question we figured out the probability of 4. So I'll substitute those 3 values into this equation here, and it looks like this. Rather than writing it as a fifth or a decimal, I'm just going to write it all as percentages, so it's super clear. Okay, 1/5 is 20%. So now you look at this and think, what is the value of the probability of 3 that makes this all make sense? So you've got 20% plus 30% is 50%, plus the 40% is 90%. So the leftover must be 10% to bring us up to 1, which is represented by 100%. All right, so the thing that completes this puzzle is the probability of rolling a 3 being 10%. Okay? Now for C, we want the probability of the complement of 1, because it's got the little hat on. So if there's a 1/5 chance, or 20%, that we roll a 1, what's the probability that we don't roll a 1? Well, it's got to be 80%, or you can write as a fraction using this as 4/5. Okay, if the question doesn't specify whether they want a decimal or a fraction or a percentage, feel free to leave it in whatever form you like, whichever one you are most comfortable with. All right, now for D, we have the probability of rolling a 2 or a 3, but we want the complement of that. Okay, it's the whole line is above the whole thing, so we want the complement of this entire event. So first thing we'll figure out is, what is the probability of rolling a 2 or a 3? And then we'll just find the complement of that by doing the leftover, you know? So rolling a 2 is a 0.3, a 30% chance, and rolling a 3, which we figured out before, is a 10% chance. So the probability of rolling a 2 or a 3 is the 30% plus the 10%. I'm just using decimals just to spice up my life, I guess. So the probability of 2 or 3 is 40%. So if there's a 40% chance you roll a 2 or a 3, what's the probability that you don't roll a 2 or a 3? It must be 60%, or 0.6. All right, that'll about do it for today. Hopefully that makes sense. If there are any more questions, as always, please let me know. I'm happy to do some more examples if you need. But if you're feeling like this makes sense, you can get started on the questions in exercise 5E for my class, and these will be assigned to you on Google Classroom. Okay, thanks so much for watching. I'll catch you guys in the next video.